So we're going to be looking at reciprocal functions. So we're going to graph the reciprocal function of x squared plus 6x plus 8. So I've gone ahead and graphed x squared plus 6x plus 8 just as is. So I factored it. It was factorable very easily. So I found my x-intercepts were negative 2 and 0, negative 4 and 0. My y-intercept is my last term, my constant 8, so 0 and 8. I completed the square to find that my vertex is negative 3 and 1. So all that is done. Now, when I have my reciprocal function here, f of x is equal to 1 over x squared plus 6x plus 8, there's a few things that differ. The first part is vertical and horizontal asymptotes. My horizontal asymptote is always y is equal to 0, so I'm just going to do that right here. So there. So none of my graph can ever touch y is equal to 0. So that's my vertical asymptote. My horizontal asymptotes of my reciprocal function are essentially the line or the x of my x-intercepts. There is essentially my x-intercepts, and let's see right here. So one of my x-intercepts is negative 2. So my vertical asymptote would be passing through negative 2 vertically, like a straight line. There we go. I'm going to do that for negative 4 as well. There we go. So my line or my graph, my reciprocal function graph can never touch these two lines. They're never going to touch these two lines. So my vertical asymptotes are at my x-intercepts, a vertical line through my x-intercepts, and my horizontal asymptote is y is equal to 0. Now, starting to graph this, we have something called invariant points. Invariant points are always present at y is equal to plus or minus 1, y is equal to positive 1 and negative 1, and that is where my reciprocal function is, the graph of my reciprocal function is going to intersect my parabola. So here if I see positive 1, I can see an intersection point here and here. We're just going to draw an approximate graph here. So negative 1, uh, I can see it intersects here and right here. There we go. So after all these points are taken, now one thing that we know is as as my y value keeps getting bigger, my graph keeps getting closer and closer to my asymptotes. So as my y here keeps getting bigger, as 1, 2, 3, 4, 5, 6, 7, 8, and as my x keeps getting bigger here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it gets closer to my asymptotes. Now we can put that into perspective here. Let's say I want to graph x is equal to 1. So I have 1 over 1 squared plus 6 plus 8. 1 is equal to 15. And now if C point is 1 comma 1 over 15, and it's very close to our vertical our horizontal asymptote of y is equal to 0. Now, yeah, so as we get greater in our x-axis and greater in our y-axis, we get closer and closer, or our graph gets closer and closer to our asymptotes. Also, I only graph my reciprocal function where I have graphs. So here I've divided my graph into 6 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant, fifth quadrant, and sixth quadrant. My graphs can only be in these 6 quadrants, and they can only especially be in the quadrants that have the parabola going through them. So quadrant number 5 has parabola going through it, so that's valid. There's no lines here, no lines here, no lines here. Oh, sorry, there is line here, so this is valid. This is my reciprocal function is going to go there. Sorry, the graph of my reciprocal function rather. There's nothing in 2, but there is some in 3, so that's going to work. Now, time to graph my reciprocal function. Now I know one of my graph is going to be here, so from my invariant point, it's going to get closer and closer to my asymptote. But it's never going to touch my asymptote, so it's just going to get closer and closer and closer and closer. There we go. And this side's going to be the exact same. They're just gonna get closer and closer and closer. It's never gonna touch my asymptote, however. Now for this side, same thing. My y is equal to 1 intersects here. So, oh no. There we go. Approximately, I just erased that by mistake. So there we go. And we get closer, 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 closer. We never touch the asymptote though. And then this gets closer and closer and closer and closer and closer. Same thing here. We have our -1 and there's two intersection points. So as we get closer, 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 we do not touch that though. And same thing here. And there we go. That's our graphing a reciprocal function approximately.